Hello, my name is Daniela, and today I will be discussing the effects of low testosterone and high-fat diet on neuroinflammation in the central and peripheral nervous systems. To give you some background information, inflammatory pathways can contribute to several diseases, including type 2 diabetes and Alzheimer's disease. And there are many factors that can help regulate inflammation. And the two that I'll be looking at today are diet-induced obesity and testosterone. Now, first, diet-induced obesity can result in decreased testosterone levels, and it can also result in the pathogenesis of type 2 diabetes. In addition to this, testosterone can lead to decreased inflammation, specifically pro-inflammatory cytokine, which I'll be discussing briefly. However, it's unclear how diet-induced obesity and testosterone can have an effect on inflammatory pathways, specifically in the nervous system. Throughout this speech, I will be talking about pro-inflammatory cytokines, and just to give you an idea of what these are cell signaling proteins that promote inflammation, and the two that we will be discussing in further detail are IL-1 beta and TNF alpha. And we will use these as markers for inflammation in the brain. So in this study, we hope to understand the independent and cooperative interactions between low testosterone and obesity on 1, metabolic events, 2, pro-inflammatory cytokines in the central and peripheral nervous systems, and 3, on neuron health in the central and peripheral nervous systems. Overall, we expect that low testosterone will worsen neuroinflammation, and we expect that high-fat diet will further exacerbate neuroinflammation. However, we also hope that testosterone replacement therapy will help reverse some of these negative effects. In addition to this, we hope that our understanding between the relationship of low testosterone and obesity on neuroinflammation will help us create new therapies to treat inflammatory diseases. Just to give you an idea of our experimental design, we use 3-month-old male wild-type mice. We used 6 mice per group, and we had a total of 8 groups. The first mouse was called sham castrated, and this served as our primary control. The second mouse was ganectomized and castrated in order to remove testosterone from the mouse body. And the third mouse was ganectomized and then given testosterone replacement therapy. And then we further divided these 2 groups into 2 subgroups, one on a normal diet and the other on a high-fat diet. And then we analyzed our data as follows. We measured blood glucose every 4 weeks, and after 16 weeks, we collected blood and tissues, and we prepared for glia culturing. And we used our glia cultures from our treated mice, where we took the cortex from our mice, and we prepared mixed glia cultures and neuron glia co-cultures. And in addition, we also harvested the cortex and sciatic nerve tissues so we can measure mRNA using PCR experiments. And this is where I primarily contributed to this study. So the first thing we looked at were the effects of low testosterone and obesity on metabolic events. The first factor we looked at was body weight, and here we found that only high-fat diet conditions resulted in an increased body weight, and testosterone manipulations did not have a negative effect on body weight. However, we did find that fasting blood glucose, fasting insulin, insulin resistance, and glucose tolerance tests were negatively affected by obesity and testosterone manipulations. The next feature we wanted to look at were the effects of testosterone and diet manipulations on inflammation, specifically inflammation in the central nervous system. And the way we looked at this was we looked at pro-inflammatory cytokines in the cortex of our mice brains. And what we found was that when we depleted testosterone levels, pro-inflammatory cytokines like TNF alpha and IL-1 beta increased. And when we replaced testosterone, we found that these inflammatory cytokines were reversed back to normal levels. In addition to this, we also found that a high-fat diet further exacerbated the effects of neuroinflammation. So the next thing we wanted to look at was the effects of testosterone and diet manipulations on inflammation, specifically in glia cells. And we looked at glia cells because these cells have been shown to be sources of inflammatory molecules in the brain. And here we found that only high-fat diet resulted in increased inflammation in glia cultures, and testosterone manipulations did not have these same effects. So in addition to looking at pro-inflammatory cytokines in the central nervous system, we wanted to see how hormone and diet manipulations affected neuron health. So we looked at neuron viability and neurite outgrowth. And here we found that only high-fat diet reduced neuron viability and also reduced neurite outgrowth. However, testosterone manipulations did not have these same effects. So now that we found that there is some effect of testosterone and high-fat diet on the inflammation in the central nervous system, we wanted to see if these effects were also present in the peripheral nervous system. And we analyzed this by looking at pro-inflammatory cytokines and also a myelin sheath marker in sciatic nerve tissue. And we found that pro-inflammatory cytokines are increased when testosterone is low. And in addition to this, high-fat diet further increased inflammation in the sciatic nerve tissue. And we also looked at a myelin sheath marker, we call this PO, and myelin sheath was decreased when there was low testosterone, and when we were under high-fat diet conditions, myelin sheath was further decreased in sciatic nerve tissues. So overall, if we take a look at the big picture, we see that obesity and low testosterone and also type 2 diabetes can all work to increase inflammation. And also these factors, and including inflammation, can all work to magnify each other's effects. And overall, we found that increased inflammation can have adverse effects on both the peripheral and central nervous systems. So if we look at all our data, we found that the combination of low testosterone and high-fat diet resulted in the poorest metabolic and inflammatory outcomes. And this is partly related to the increased pro-inflammatory cytokines in the central and peripheral nervous systems, and also the effect of high-fat diet on reducing neuron health. We also found that testosterone replacement therapy can have some therapeutic effects on neuroinflammation. So in the future, we hope to use our understanding about inflammatory pathways to help treat inflammatory diseases like type 2 diabetes or Alzheimer's disease. And specifically, we would target low testosterone or maybe obesity or even a combination of the two. Also, we recently submitted our data to the Journal of Neuroinflammation. And please, if you have any further questions, please contact me. My information is listed here. And I hope you enjoyed my presentation, and thank you so much for your time.